Hello and welcome, dear mathletes, once again to Mathlete Minds. We continue our journey of coordinate geometry, and here in this particular video, we'll extend to section formula, the second formula that we have to know based on CBSE Class 10 syllabus. So first of all, we'll try to understand the formula, and then we'll do some simple applications of the formula. So let's see what the formula is all about. The formula is section formula, which of course tells us that we are dividing a particular line into two parts. Section, we are making the sections of that particular line. So here we have a straight line, and A and B are 2 points on the line with the coordinates x1, y1, x2, y2. And C is another intermediate point in between these 2 points, which is dividing the length of AB in two parts in the ratio m is to n. In the second figure over here, you find that the C is a point outside the line. So this is external division. This is called internal division. So you must be able to distinguish between internal and external division. But in class 10, we are going to do only internal division. So we have to relate ourselves or confine ourselves to internal division. Now, what is the formula about? So here, basically, we will find out the coordinates of this point C, which is dividing the line AB in the ratio m is to n. So x will be given by mx2 plus nx1 by m plus n. And y will be given by my2 plus ny1 by m plus n. If C is the midpoint, then m is to n becomes 1 is to 1. So in that case, x is given as x1 plus x2 by 2. And y is given as y1 plus y2 by 2. And supposing the ratio is not given in terms of m is to n, it is given as k is to 1. In that case, the formula becomes x is equal to kx2 plus x1 by k plus 1. And y becomes equal to ky2 plus y1 by k plus 1. We'll see how this formula comes into existence in the next slide. So taking the next slide, we have here the figure drawn for it. We have 2 points A and B with the coordinates x1, y1 and x2, y2. And there's a third point P which divides it internally in the ratio m is to n. We have drawn perpendiculars AN, PN and BN. And we have also drawn perpendiculars AD and PQ. Now remember, we are doing this derivation in the first quadrant, but that does not mean this formula is not applicable to points in other quadrants. Same formula is applied in other quadrants also. Only thing is we have to be very careful with the signs. In the first quadrant, all the signs are positive, so it doesn't make a lot of difference. Now, let's come back to the derivation. Now, these are all perpendiculars over here. This is the perpendicular, this is the, all these lines are perpendiculars over. So, obviously, AM is parallel to PL is parallel to BN and AD is parallel to PQ. So, next what we do is we take these two triangles. Obviously, these two triangles will be similar because this is 90, this is 90. These two lines are parallel. So, you get over here this angle equal to this angle, a pair of corresponding angles. Similarly, these two lines are parallel and AB is the transversal. So this angle becomes equal to this angle, that is PBQ and APD. So based on this, we can write down over here triangle APD is similar to triangle PBQ by angle-angle criteria. So the sides are proportional, therefore AP by PB is equal to PD by BQ is equal to AD by PQ. So AP by PQ, that is M is to N. PD, now what is PD? PD is this length. So this whole vertical length is Y and PD will be equal to PL minus DL. If we calculate here, PD is equal to PL minus DL. Now, DL is also equal to AM. This forms a rectangle over here. So, we can write it as PL minus AM. So, this becomes equal to Y minus Y1. So, PD is Y minus Y1. BQ. BQ is this line. So, this is BQ is equal to this BN minus QN. That is equal to BN minus PL, that is Y2 minus Y. So we get here y2 minus y. Similarly, AD will be equal to x minus x1 by x2 minus x. Now we'll take this proportion first, the first two, and then we'll take the first and the third one. So m by n is equal to y minus y1 by y2 minus y. On cross multiplication, you get here my2 minus my is equal to ny minus ny1. So segregating the terms, keeping the y terms together, we get over here my2 plus ny1 is equal to my plus my plus ny. Take out y common, you get left with m plus n. And this is my2 plus ny1. So now y becomes equal to my2 plus ny1 by m plus n. Similarly, x will be equal to mx2 plus nx1 by m plus n if you take the first and the third proportion, third ratio, and make it a proportion and solve it this way, you get this value. So y is m by 2 plus n by 1 by m plus n, x is mx2 plus nx1 by m plus n. Important thing to remember over here is n is multiplied by the opposite coordinate, that is x2, and n is multiplied by x1. So mx2 plus nx1 by m plus n. Next one is find the coordinates of the point which divides the line segment joining the points minus 1, 3, 4, 7 internally in the ratio 3:4. So this is the first application that we are doing over here, 3:4. So this point is dividing the line segment joining these 2 points in the ratio 3:4. So you have to be careful while writing the ratios over here. The first coordinate was minus 1, 3, 4, minus 7. And this line is being divided internally, so 3:4 will be this way. So x will be equal to, now we know the formula, x is equal to mx2 plus nx1 by m plus n. And y is equal to my2 plus ny1 by m plus n. So if we get back to this calculation over here, mx2 will become 3 into 4 n plus 4 into minus 1 by m plus n, that is 7. So this is 12 minus 4 by 7, that is 8 upon 7. Similarly, y will be equal to m, that is 3 into minus 7, 3 into minus 7 plus 4 into 3 by 7, that is minus 21 plus 12 by 7, that is minus 9 by 7. So the coordinates of C, the point C are, C is 8 upon 7, comma, minus 9 upon 7. So this was how we applied it in the first very simple of questions. Moving on to the next question, here we have, if the midpoint of the line segment A3, 4 and BK, 7 is CXY and 2x plus 2y plus 1 is 0, find the value of K. So in this particular question, the point is given as the midpoint. So that means m is to n is 1:1. So we need not talk about m and n over here. Its ratio is 1:1. So x will become equal to x1 plus x2 by 2 and y will become equal to y1 plus y2 by 2. So first of all, we'll find x1, x2, and then we have this condition given, xy lies on this line. It justifies, the value of xy will justify this equation of the line. So let's see what we have to do. X is equal to 3 plus k by 2 and y is equal to 4 plus 7 by 2. So now if we put the value in this equation, 2x plus 2y plus 1 is 0. We get over here 2 into 3 plus k by 2 plus 2 into 4 plus 7 by 2 plus 1 is equal to 0. 2 gets cancelled. So k plus 3 plus this becomes 11 plus 1 is equal to 0. So k automatically becomes equal to minus 15. So k value is minus 15. So once you know k value, you can even find x and y. Next question is, find the ratio in which the point P2, y divides the line segment joining the points minus 2 to B3, 7. So here you are given this point 2, y. It is dividing this line. and we have to find this ratio in which it is dividing this line. So this is a reverse process. You're finding the ratio now. The point is given, but both the coordinates of the point are not given. So what we need to keep in mind is we'll take the point that is given. The point is x coordinate. So we'll take 2 as the point as 2 as the x coordinate over here. So 2 becomes equal to 3m minus 2n by m plus n. On cross multiplication, you get here 2m plus 2n is equal to 3m minus 2n. So this becomes equal to minus m is equal to minus 4n. So m by n is equal to 4:1. So the ratio is 4:1. So now we can even find out y. So y will be equal to 4 into 7 plus 1 into 2 by 5. So 28 plus 2, 30 by 5, that is equal to, this is 28 and this is 2. 28 by 2, that is 6. So y is equal to 6. So 2, 6. The coordinate y is equal to 6. Next question is, in what ratio is the line segment joining the points -2, -3, b 3, 7 divided by the y-axis? Also find the coordinates of the point of division. So this is the point which is dividing the line AB. Important thing mentioned over here is divided by the y-axis. So we must remember whenever we take a line which is being divided by the y-axis, the x coordinate will be 0. And if we have to find the coordinates of the point on the x-axis, the y coordinate will be 0. So the point of division over here, that is 0y. So here we take the help of the 0. It was not mentioned. But after reading the question, you have to analyze it this way and take the x coordinate as 0. So 0 is equal to, now this is m is to n. So we'll find 0 is equal to 3m minus 2n by m plus n. So on simplification, you get here 3m minus 2n is equal to 0. So 3m is equal to 2n. That means m by n is equal to 2 by 3. So the ratio is coming as 2 by 3. Now find the coordinates of the point of division. So one coordinate is 0. The other coordinate y will be equal to 2 into 7. 2 into 7 plus 3 into minus 3 by 5. So this becomes 14 minus 9 by 5, that is 5 by 5, that is 1. So the coordinates of the point of division are 0, 1. So C is represented by 0, 1. The next question is, find the coordinates of the point A, where AB is the diameter of a circle, whose center is 2, minus 3 and B is 1, 4. So this is the center over here. So obviously the center of the circle, and AB is the diameter, so AC and CB, they will be equidistant from the center. The point A and B will be equidistant from the center. So AC is equal to CB is the radius. So here we'll take the help of the midpoint formula. So C, that is the coordinate x is given, this is x1 plus x2 by 2, the midpoint formula. Y is y1 plus y2 by 2. So 2 over here, that is x, is equal to x plus 1 by, here x, y are the coordinates of A, x plus 1 by 2. So this means x is equal to 4 minus 1, that is 3. So the coordinate x is 3. Now what about the second coordinate y? Y will be equal, minus 3. Minus 3, the midpoint is equal to y plus 4 by 2. So y will become equal to minus 6 minus 4, that is minus 10. So the coordinates of A are 3, minus 10. These are the coordinates of A. Here this is xy. So here I have to place over here minus 3, the midpoint over here. This is minus 3. Next question is, find the length of the median from the vertex A on BC in a triangle ABC having the vertices A51, B15, C minus 3 minus 1. Now first thing we have to get back to the definition of a median. Median divides the line, the side opposite where, from the vertex, like it is being drawn from the vertex A on BC. So it will divide the side BC into two equal parts. Always a median divides the side into two equal segments. So D becomes the midpoint. And we have to find the length of the median. So here, first of all, we'll find the coordinates of D. So X becomes equal to, we'll use the midpoint formula, 1 minus 3 by 2, that is minus 2 by 2, that is minus 1. Y will become equal to 5 minus 1 by 2, that is 4 by 2, that is equal to 2. So the coordinates are minus 1, comma 2. Now we'll find the length AD with the help of the distance formula, which we have done in the previous video. So AD will be equal to 5 plus 1 the whole square plus 1 minus 2 the whole square under root. So this becomes 6 whole square, that is 36, plus 1 the minus 1 the whole square, that is 1. So this is equal to root over 37 units. So AD length is root over 37. I hope it is clear till here. Next question that is there is, three consecutive vertices of a parallelogram are given as minus 2, comma minus 1, 1, 0, 4, 3. Find the fourth vertex. So it's mentioned here consecutive. That means we have to put them in order. This is minus 2, comma minus 1, this is 1, 0, and this is 4, 3. And this is the fourth vertex dxy. We have to find the coordinates of dxy. Now, we must remember over here in this particular parallelogram question that the diagonals of the parallelogram bisect each other. We get back to the properties of the parallelogram. The diagonals of the parallelogram bisect each other. So let us take this point of bisection as alpha beta. The point as O and the coordinates as alpha beta. So obviously O becomes the midpoint of the diagonal AC as well as O becomes the midpoint of the diagonal BD because it's a point of bisection. So here alpha, when we take the diagonal AC into consideration, when diagonal AC is taken into consideration, alpha will be equal to minus 2 plus 4. Minus 2 plus 4 by 2. So this becomes 2 by 2, that is 1. And when we beta will be equal to, in the same diagonal, beta will be equal to minus 1 plus 3 by 2, that is 2 by 2. So we get over here, that is 2 by 2, that is 1. Now if we take the diagonal BD, now in the diagonal BD, alpha will be equal to x plus 1 by 2. And beta will be equal to y plus 0 by 2. So now both the alpha and beta, whether you are taking the diagonal BD or whether you are taking the diagonal AC, they will be equal. So from here we get x plus 1 by 2 is equal to 1, equating it with this alpha value. So x plus 1 is equal to 2, that means x is equal to 1. Similarly, we can take y plus y by 2 is equal to 1, so y is equal to 2. So the coordinates of this point D are, so D point is given as 1, comma 2. So this is how, whenever we get the parallelogram question, always this property of the parallelogram, that is the diagonals bisect each other, must be taken into consideration. The next question is, the vertices of the triangle ABC are A55, B15, C91. A line is drawn to intersect AB and AC at P and Q such that AP by AB is equal to AQ by AC is 3 by 4. Find the length of the line segment PQ. So we have to find the length of the line segment PQ. Now what are the things given over here? First of all, we are given here the ratio of AP upon AB is equal to AQ upon AC. That is 3:4. And we do not know the coordinates of P and Q, so we need to find out the coordinates of P and Q to find the length of PQ. So what we do first is, now AP upon AB, that is equal to 3 upon 4. So we can rewrite this as AP upon AP plus PB is equal to 3 upon 4. On cross multiplication, 4AP is equal to 3AP plus 3PB. So this becomes AP is equal to 3PB. So that means if we take the ratio AP upon PB, that will be equal to 3PB upon PB, that is 3:1. So the ratio becomes 3:1. It can also be done logically because this total is 4 and this is 3, so obviously this will be 1 part. But sometimes you need to show it in certain questions, so take it as understand the method also. 3 is to 1. Now this will also be 3 is to 1. Supposing the coordinates of P are x1, y1 and the coordinates of Q are x2, y2. So x1, y1, let's first find out x1. So x1 will be equal to 3 into 1, 3 into 1 plus 1 into 5 by 4. So that is 5 plus 3, 8 by 4, that is 2. Y1 is equal to 3 into 5, 3 into 5 plus 1 into 5 by 4. 15 plus 5, 20 by 4, that is 5. So P becomes 2, 5. X2 will be equal to 3 into 9, 3 into 9 plus 1 into 5 by 4. That is 27 plus 5, 32 by 4, that is 8. Y2 will be equal to 3 into 1, 3 into 1 plus 1 into 5 by 4. That is 8 by 4, that is 2. So coordinates of Q become 8, 2. Now we need to find out the distance PQ. So we take the coordinates P as 2, 5 and Q as 8, 2. And we find the distance. The coordinates are 2, 5 and 8, 2. So the distance will PQ with the distance formula will be done as 2 minus 8 the whole square plus 5 minus 2 the whole square under root. So 2 minus 8, that is minus 6, that is gives us 36 and this is 9. So root over root 45. So this can be written as 3 root 5 units. So the distance PQ is 3 root 5 units. Now, we have taken up very simple questions in this particular video pertaining to section formula. The next video will have some more questions of section formula, slightly of a higher order, and different varieties of parallelogram question. So wait for the next video. Thank you for watching. Hope you have understood the questions and the solutions, and to some extent it has become easier to understand this particular chapter. Kindly like, share and subscribe to the channel. Thank you for watching.